This is going to be a very short video on doing hypothesis tests to evaluate normality. So remember that if we're going to do a test for means, so maybe I want to test a null hypothesis that the mean is equal to 7, or maybe I'm doing a two-sample test where I want to test whether the mean from population 1 is equal to the mean from population 2. And suppose that I want to do this with a t-distribution. So t-distributions, recall, assume that the population distribution is normal. That's the first assumption that it makes. And if we don't have normality, the t-test has questionable validity. Now, let me remind you that if the sample size is moderately large, even modestly large, the central limit theorem can be used to establish the normality of x bar. But if we have very small sample sizes, the normality is really important. So what I told you to do earlier was to look at a quantile plot, a normal probability plot, to evaluate that normality. And you probably also want to look at maybe a histogram also to judge this. But we know that normal probability plots are sometimes hard to interpret. So we want them to look like a line, but sometimes there's just random variations that don't look like a line. So there are many tests out there that can be used to kind of help us judge whether a QQ plot is really showing non-normality, or is this just showing some random noise that could potentially happen if we had a normal distribution. So I'm not going to teach the theory behind this particular test. I'm going to teach the Shapiro test. If you're interested in the theory, I've given you a link to the Wikipedia page that explains it. So the idea with one of these normality plots is that we have a null hypothesis that the population distribution is normal. So we're going to condition on the null and compute a test statistic that indicates to what extent the observed data deviate from a normal population. So in R, there's a function called the Shapiro Test that gives us the test statistic. So what we see here is, let's just jump over to R, and I'm going to go look at a QQ plot for the frozen food data that we had earlier. And if I do a QQ line food, what we see is the normal probability plot shows that this is probably very normal. So the points on the normal probability plot fall almost exactly on a line. But let's go do the Shapiro test. So if I do Shapiro.test food, we get this p-value. Now the p-value is very large. And the fact that it is so large indicates that we cannot reject the null hypothesis that the data come from a normal population. So because it's so large, I would say it's entirely plausible that this data come from a normal distribution. I'm not saying it did. It could have come from something with slightly heavier tails like a t-distribution, but we cannot rule out the possibility that it's coming from a normal distribution. Well, let's go see a situation where we would reject it. So this word game problem was actually a problem I gave you for your homework in the confidence interval homework. But let's go look at the normality of this. So let's go make ourselves a QQ plot. So QQ norm word game. And the sample sizes in both of these examples are very small, so we need to worry about normality. And when we look at the QQ plot, it shows nothing resembling a normal distribution. If I go add the line, we don't even need to add the line. QQ line word game. Of course, it doesn't follow the line at all. The reason for this is that it's a bimodal distribution. So what's happening in this problem is that there are stores that charge full price, and then there are stores that charge a discounted price. and the discounted price pretty similar to each other. And so this is nothing resembling a normal curve. Well, if I do a Shapiro test, we would expect to be able to reject the null hypothesis that this comes from a normal distribution. Notice the p-value in this case is absolutely tiny. So it's 0.003. That's way less than the usual cutoff of, say, 5%. We would reject the null hypothesis and conclude that this data is unlikely to have come from a normal population. Therefore, the t-test would be very questionable. So if you watch my video on this particular problem, I will explain more about what we should do in this particular case. The point of this video is just to make you aware that the Shapiro test exists and can be used to inform your decision of whether normality is a plausible assumption.